Hello students, welcome back to our science class. In the previous lecture, we had studied about pressure on solids, liquid and gases. Today we are going to learn about atmospheric pressure, that is air pressure. In our day-to-day life activities, we experiences various instances of atmospheric pressure. Some common examples are sipping cold drinks through a straw, dipping the nozzle of the syringe in a liquid, vacuum cleaner, etc. Air surrounds the earth from all sides. This layer of air is called atmosphere. The atmosphere exists to about 16 km height. It further extends up to about 400 km in a very dilute form. The pressure created due to air is called the atmospheric pressure. Imagine that a very long hollow cylinder of unit cross-sectional area is standing on the surface of the earth and it contains air. Weight of this air is the force applied in the direction of the center of the earth. This means that atmospheric pressure is the ratio of this weight divided by the area of the surface. The air pressure at the sea level is called 1 atmospheric pressure. Air pressure decreases as one goes up in height from the sea level. As we go up, the atmosphere becomes thinner and thinner and its pressure also goes on decreasing. This is the reason why high pressure is found at the sea level due to dense atmosphere. The lower areas or plains have high pressure, but on the mountains the pressure becomes low. 1 atmosphere is equal to 101 into 10 raised to 3 Pascal is equal to 1 bar is equal to 10 raised to 3 millibar. 1 millibar is equal to 10 raised to 2 Pascal, that is hectopascal. Atmospheric pressure is specified in the units millibar or hectopascal. Millibar is denoted by small m and bar and hectopascal is denoted by small h p a. The atmospheric pressure at a point in air is equal from all sides. Now how is this pressure created? If air exists in a closed container, the air molecules in random motion continuously hit the walls of the container. In this interaction, a force is exerted on the walls of the container and pressure is created due to this force. Do you want to feel the air pressure? Let us feel it by doing an experiment. Take a glass of water. Take a piece of paper card which can cover the top of the glass. Hold the card on the top of the glass with your hand and rotate the glass full of water. Now slowly remove your hand from the card. Surprise! The water stays in the glass. It does not fall down. How does it happen? Let me explain it to you. The card acts as a rigid membrane between the water and the air. The air pressure pushes up on the card. Air pressure does not push down on the water because there is a vacuum on the top of the water. Although atmospheric pressure is pushing outside of the glass, this does not have any impact on the water inside the glass due to vacuum. The only force which is pushing down the water is its weight, means weight of the water itself. But the upward atmospheric pressure easily supports the weight of the water. Hence, they cancel each other and water does not fall down. Now, make a hole in the top of the glass. Now there is no vacuum above water. the air pressure would push on the top of the water. Now in this case, due to the air pressure from the top and weight of the water, overall downward pressure becomes higher than the air pressure on the card which is pushing upward. So water would fall from the glass. We constantly bear the atmospheric pressure on our head. However, the cavities in our body are also filled with air and arteries and veins are filled with blood. Therefore, we do not get crushed under water and due to atmospheric pressure as the pressure is balanced. The Earth's atmospheric pressure decreases with height from the sea level. So this pressure is maximum at the sea level and continues to decrease as we increase our altitude, that is height. Why does this happen? Why isn't this atmospheric pressure is same everywhere? So let us see this. The atmospheric pressure that acts on us is due to the weight of the closely packed air molecules. And these molecules are attracted towards the surface of the earth due to gravity. We know that the gravitational force of the earth is maximum at its surface and tends to decrease as we move away from it towards the space. Due to this decrease in the gravitational force as the altitude increases, that is height increases, the air molecules move far apart. The density of the atmosphere decreases and it gets thinner and thinner, and it subsequently decreases the atmospheric pressure. Due to this, the air pressure is always less near the mountains and the maximum at the sea level, and this phenomena makes breathing difficult at high altitudes as the air gets thinner and the molecules continue to move far apart. At the top of the Mount Everest, the air pressure is almost 1/3 of that of the sea level. To stay alive, mountaineers should carry the oxygen cylinders with them. So students, I hope you have understood what is meant by atmospheric pressure and which are the applications of atmospheric pressure in our day-to-day life. So in the next lecture, we are going to learn about buoyant force. Thank you.